3 by 5 and 1 by 2. So two different fractions we have taken here. And this, we multiply this 3 by 5. 3 by 5 we have taken. This is 1 by 2. 3 by 5 and 1 by 2. Two different types of fractions we have taken. So if we multiply with any number with 1 by 1, numerator and denominator, we get the same fraction. So let's take greater than 1. So 2 by 2. So let's see the multiplication of this two numerators and numerators. 6 by 10 will be getting. So 6 by 10 is equals to 3 by 5 because we have multiplied a constant number, the numerator and denominator will be getting equivalent to that fraction. So equal to that fraction. So this kind of fractions are known as equivalent fractions, which are equal to the fraction. For example, we'll take this 3 by 5 same as it is. 3 by 5. So we multiply 3 by 5 with 3 by 3 again. So because if we multiply with 1, we'll be getting the same fraction. So we took another 1. Already we have taken 2. So and 1, we will get the same. So next one is 3. So we have taken 3. Now 3 3s are 9 and 15. So 9 by 15. We call this fraction. This is equivalent to the fraction of 3 by 5. When we cancel this 3 table, 3 by 5 will be getting. So this is equivalent to 3 by 5. And 6 by 10 is also equivalent to 3 by 5. And so let's multiply with 4 also. 3 by 5 will take now. So 3 by 5 should be multiplied with 4 by 4. So we'll be getting 12 by 20. So 12 by 20 is equivalent to 3 by 5. So equal to 3 by 5. So this kind of fractions are known as equivalent fractions. So let's see, let's observe. This is here 6 by 10, 9 by 15 and 12 by 20. These all are equivalent to the fraction of 3 by 5. So 6 by 10 is equivalent to 3 by 5. 9 by 15 also equivalent to 3 by 5. 12 by 20 is also equivalent to 3 by 5. So these all are equivalent fractions. These all are equal to 3 by 5. That's the reason we call them equivalent fractions. So 2 table we cancel, 3 by 5 will be getting. 3 table we cancel, 3 by 5 will be getting. And there also we cancel 4 table. So 3 by 5 will be getting. So this is the concept of equivalent fractions. Let's take some other example, that is 1 by 2. It should be multiplied with. So we take the other than 1. So 2 by 2. We'll be getting 2 by 4. Next one is, so 1 by 2. We'll multiply with 3 by 3. So we'll be getting 3 by 6. And 1 by 2 is multiplied with 4 by 4. So we'll be getting 4 by 8. So the fractions we got here is, the fractions we got here are 2 by 4, 3 by 6, and 4 by 8. All these fractions are equivalent to 1 by 2. So 1 by 2 is equal to 2 by 4. This both the fractions are equal. 1 by 2 is equal to 3 by 6. And 1 by 2 is equal to 4 by 8. These all the fractions are equal. So we call these all the fractions are equivalent fractions. So this is the concept about equivalent fractions. Let's go to the next concept, that is simplest form of the fractions. Simplest form of the fractions. So we take any one fraction like 198 divided by 46. So we got a fraction here, and then we need to simplify this fraction. Simplify simplest form. In simpler form we need to write. So this is a fraction. In this fraction we can observe there is a common factor or multiple. We can take common factor of 2 because it's 198. It's a even number and 46 is also even number. We'll be getting 2 as a common factor in this. So if we take this 2 as a common factor in this, so we'll be getting into 2. If we take 9 2s are 18, 9 2s are 18, 99 into 2, we'll take it. So the denominator part, we take 2 as a factor of it. So 2 3 23, 2s are 46. So if we observe this 99, if we take the common factor of it, 2 by 2. So these both are same, the numerator and denominator. As we know 2 by 2 is what? So we can cancel 2 by 2. So we'll be getting 99 by 23. So let's see any one of the common factor is present in these two, the numerator and denominator. So 99 and 23, 99 it's a factor of 3, but 23 is not a factor of 3. So 23 is a prime number, we will not get in any table except that number and 1. So there is no common factor is present in the numerator and denominator. So this 198 by 46 we have simplified, and the simplest form of it is, after taking all the common factors from it, is 99 by 23. So this is the simplest form of the fractions we call. Now let's take some other example. That is 125 by 40. So the fraction. So this also we can simplify. So there is a common factor in this both, that is 5 we call. So we take in a common factor because we can say this is a common factor is the last digit of these numbers is 5. So 5 is a factor of, this is divisible by 5. So this number, whole number is divisible by 5 because we know the divisibility properties. The last unit is divisible by 5, then whole number is divisible by 5. Or the unit digit is divisible by, the unit digit is 0, then also divisible by 5. So the unit places are 5 or 0, then whole number is divisible by 5 we say. So from divisibility properties, so this both the numbers are divisible by 5. So that's the reason we are taking 5. So 5 and we take, so 2 times 5 times 25 5s. So when we take the denominator 5, so we'll be getting 8. So we know that it's 5 by 5 is 1. So we'll be getting remaining number, that is 25 by 8. So let us see. So 25 is not a prime number, it's a composite number. But 8, it is also composite number. But these two are both primes, it doesn't have any common factors. So we cannot do any simplification of 25 by 8. So after simplifying this fraction of 125 by 40, we got the simplest form of is 25 by 8. So this is a concept about simplest form of fractions. So let's go to the next concept, that is comparison of order of fractions. So let's see the concept of comparison of order of fractions. Some of the pictures. We have taken the diagram of triangle. So in this, divide this triangle into some of the parts. This is divided into 2 parts, and this is divided into 3 parts. And this is divided into 6 parts. So we got here 3 triangles, and we divided these triangles into some of the parts. This is first triangle. We have divided into 2 parts, and this is 3 parts and 6 parts we have divided. So let us shade one of the part from it. So this is, we shade one of the part from it. Out of 2 parts we have divided one of the part. So this is, and this is already it's divided into 3 parts. We have shaded only 1 part from it. So, and this, we divide this, we shade one of the only 1 part from this third triangle. So from the first triangle we have taken 1 part, the second triangle also 1 part, third triangle also 1 part. Let's see how we need to represent this picture as a fraction. So fraction is nothing but a part of a whole, the part of a whole. So the whole is nothing but 2, because there are 2 parts are present in this. Total parts represented in this are 2. So we have taken 2. So out of 2 we have shaded 1. So it is 1 by 2. Recall, it's 1 by 2. So next one is 1 by 3, because these total parts are 3 in this. We have divided to 3 parts. So out of 3 parts we have taken 1 part from it. So it's 1 by 3. So next one is, that is 6 parts we have divided. So out of 6 parts we have taken only 1 part from it. So 1 by 6. So 1 by 2, 1 by 3 and 1 by 6. So these are the fractions we have taken. So always we know that when we have taken 1 triangle, when divided into 2 parts, the 2 parts, 1 part we took from it, and it will be greater than to 3 parts when we divide it. Because we take, on the example, we take an apple and we divide it into 2 parts, we'll be getting 2 parts. So that parts, each part will be getting. So from that half of the part we take and eat, it's we get half of it. And then the same example in another situation, if we cut that apple into 3 parts, so now we take that apple and eat. What we observe, that what we have eaten previously into 2 parts we have divided and we got a piece of it that is greater than this. So in the next situation, if you take an apple and cut it to 6 parts, 6 equal parts, so we get a small piece of it which is very less than the previous one and also before one. So the 6th part is always less than 3rd part, the 3rd part is always less than the half of it. So in this similar manner, and this 1 by 2, half of the triangle is always greater. It's greater than 2, or so 1/3 of triangle. So, and 1/3 is always greater than 1/6 of a triangle. So in this manner we can compare the triangles. We can compare the fractions in this manner. So 1 by 2 is greater than 1 by 3. So greater than 1 by 6. So always this 1 by 2, we'll take it as a picture in this manner. So this is the concept about comparison of order of fractions. So let's see next concept, that is fractions with the same denominators. Fractions with the same denominators. 1 by 2, 3 by 2, 5 by 2. So 4 by 2. And these fractions we have taken which are having the same denominators. And when they are having the same denominators, so the fractions can be added directly. So like 4 by 2, 1 by 2, these are like fractions we call. Earlier we have discussed about types of fractions. In that, like fractions are present. The like fractions are nothing but which are having the same denominators. So if the like fractions are there, and then we can do the simplification of it, like addition or subtraction we can do of it. So 4 by 2, 1 by 2, 3 by 2, 5 by 2, and these all the fractions can be added because these are like fractions. Like fractions can be added, so which are having the same denominators, we call them like fractions. Like fractions always can be added, like and this 2 is the denominator, and when the denominator is same, we'll take the numerator parts, that is 4 plus 1 plus 3 plus 5, and we'll add up all the numerators when the denominator is same, and we can observe there is a denominator of 2, but we did not take all the 2s are present in this 4 times of 2, we did not take, we took only one time of it, that is 2 we have taken. So numerators are 4 plus 1 plus 3 plus 5, so let's add this all. 5 plus 3, 8, 9, 9 plus 4 is 13, 13 by 2. So in this manner, we will take the fractions which are having the same denominators and add up in this manner. And fractions which are having this different denominator, fractions which are having the different denominators. So if the denominators of the fractions are different, like 5 by 2, 1 by 2. So in this, the denominators of the fractions are different. So we cannot do the addition of it or subtraction of it. So because these are unlike fractions we call. So unlike fractions, we cannot add or subtract. So we need to make this denominators equal and add them. So we need to make the denominators are equal. So to do that process, so we need to take the LCM of these denominators first. So let's take the LCM of 3 and 2. LCM of 3, 2. That is, we don't get this 2 doesn't have any common factors. So LCM will be directly will be getting 3 into 2. That is 6. 6 will be LCM for both the denominators, that is 1 by 3, so 5 by 2. So we need to get the LCM, the 6. So 3 table will be getting 6, that is 2 by 2 times. So why the reason of taking 2 by 2 is, so 3 table is a 3 denominator, will make the denominators equal. That's the reason we have taken the LCM, common factor we have taken. So 6 is a common factor for 3 and 2. So 3 table will be getting 6. 3 table 2 times 6. That's the reason we have taken 2 by 2. So here we need to get 6. So 2 table will be getting 3 times 6. That's the reason 3 by 3. So 3 times 6. So 3 by 3. So let's multiply this. The fractions after multiplying numerator and denominator we have taken 2, there also we have taken 3 by 3. So 2 by 6 and 15 by 6. So let's observe these two. Now you can compare these fractions easily, which are having same denominator.